40 light-years from Earth, there are 7 worlds the size of our own, orbiting a single dim star, and at least 3 of them sit in exactly the right zone for liquid water to exist on their surfaces right now. Think about what that actually means. Not 1 candidate for life, not 2. 7 planets packed into a system smaller than the distance between our Sun and Mercury, each one roughly the size of the world you're standing on. This is the TRAPPIST-1 system, and it may be the most important place we've ever pointed a telescope. But here's the question that keeps astronomers awake at night, and the one we're going to chase through this entire video. Do any of these worlds have an atmosphere? Because without one, the dream dies before it starts. And the answer, as we're about to find out, is far stranger and more complicated than a simple yes or no. Let's start with the discovery itself, because the story of how we found TRAPPIST-1 tells us a lot about why it matters so much. In 2017, NASA announced that the TRAPPIST-1 system harbored not 1, not 3, but 7 Earth-sized planets. The announcement shook the scientific world. It was the largest batch of Earth-sized, potentially habitable worlds ever found around a single star. The name comes from the telescope that first spotted them, the Transiting Planets and Planetesimals Small Telescope, based in Chile. Researchers watched the host star dim in a very specific, repeating pattern, the telltale signature of planets crossing in front of it, one after another like beads on a string. The star itself, TRAPPIST-1, is nothing like our Sun. It's an ultra-cool red dwarf, so small and faint that if you replaced our Sun with it, the sky from Earth would be perpetually dark. You'd need to orbit 30 times closer just to feel the same warmth we do here, and that's exactly what these 7 worlds do. They're packed in tight, all 7 completing their orbits in less than 20 days. From the surface of any one of them, the other planets would appear enormous in the sky, close enough that you could theoretically see their continents. Now here's where the story gets complicated, and this is the open question that the entire astronomical community is wrestling with right now. Just because a planet sits in the habitable zone doesn't mean it's actually habitable. Mars sits close to the edge of ours, and look how that turned out. The critical ingredient isn't just the right distance from the star, it's atmosphere. A thick enough blanket of gas to trap heat, regulate temperature, protect the surface from radiation, and, if we're lucky, hold liquid water in place. And red dwarf stars like TRAPPIST-1 are notoriously violent in their youth. They blast out flares of ultraviolet and X-ray radiation that could strip a young planet's atmosphere clean in just a few 100 million years.
So the billion-dollar question, and I mean that almost literally, given what NASA has invested, is whether any of the TRAPPIST-1 planets managed to hold on to an atmosphere despite billions of years of stellar bombardment. Enter the James Webb Space Telescope. This is where the story pivots from beautiful theory to actual data. Webb was specifically designed in part to answer this exact question. It observes an infrared light, which allows it to detect the faint heat signatures of planets and, crucially, to analyze starlight as it filters through a planetary atmosphere. Each molecule, carbon dioxide, water vapor, methane, leaves a distinct fingerprint in that light. It's called transmission spectroscopy, and it's the closest thing we have to sniffing an alien planet's air from 40 light-years away. In 2023, Webb delivered its first verdict on the system, targeting TRAPPIST-1c, the second planet from the star. TRAPPIST-1c sits just outside the habitable zone, receiving roughly the same amount of energy as Venus does from our Sun. Scientists suspected it might host a thick carbon dioxide atmosphere similar to Venus. What Webb found instead was nothing, or close to it. The planet appears to be bare rock, with no substantial atmosphere detected. That's not the hopeful result everyone was hoping for. But here's why it's not the end of the story. That result actually tells us something crucial. It rules out a Venus-like thick atmosphere on 1c. But the inner planets, particularly TRAPPIST-1b, were already expected to be too hot. The real prize is further out. TRAPPIST-1e, 1f, and 1g are the 3 worlds sitting firmly in the habitable zone, and Webb hasn't finished examining them. The absence of atmosphere on 1c narrows the field without closing it. Science doesn't always hand you a triumph. Sometimes it hands you a sharper question. And now we reach the moment that I think should genuinely shift the way you see this system. Astronomers have calculated that the TRAPPIST-1 planets are likely tidally locked. That means each planet always shows the same face to its star, one side in permanent scorching daylight, the other in permanent frozen night, with a narrow twilight ring in between. That sounds catastrophic for life. But here's the twist. Some climate models suggest that a tidally locked planet with the right atmosphere could actually circulate heat efficiently enough from the day side to the night side to create a habitable band.
and that liquid water could pool precisely in that twilight zone. Life, if it exists there, would exist in an eternal alien dusk. We don't know if that's happening. We genuinely don't know yet, but Webb is still watching. Observations of TRAPPIST-1e and the other habitable zone worlds are ongoing. Each observation cycle adds data. Each data point either builds a case or eliminates one. This is science moving in real time, and the answer could come within the next few years. 7 worlds, 1 quiet red star.
And a question so large it touches on whether life in this universe is a miracle or a pattern. If the James Webb Space Telescope detects even a hint of a complex atmosphere, water vapor, carbon dioxide, or something we don't expect, around one of those 3 inner habitable zone worlds, it will be the most significant scientific discovery in human history. Not might be, will be. That's what's at stake every time Webb points itself at a dim red star 40 light-years away. If this kind of deep space storytelling is what you come here for, hit subscribe. We're just getting started. And leave a comment below. Which of the 7 TRAPPIST-1 worlds would you want to stand on, and why? Next time, we're going somewhere even stranger. A place where it rains iron and the wind moves faster than sound. You won't want to miss it.